Welcome to Breadboarding. This is video 20 in the Breadboard 8088 PC series, and it's also the 8th in the series looking at building out a Monochrome Display Adaptor video controller which is compatible with the original IBM PC. So in the previous video we added the CRT status and control registers and also the blink clock necessary to generate the signals for the cursor and the character blinking. In this video we're going to be adding the attribute latch, the attribute multiplexer and the video output PLD. If we have time we may go on to do some testing, but I suspect we may run out of time and we'll do the testing in a future video. So if we take a look at the block diagram that we've been working from, in the previous video we added the blink PLD, CRT control port and the CRT status port, and those are necessary, as we'll see, to enable all of the features we're going to be adding in this video. So I've added cursor highlighting as a result of some feedback. I think it was from Bill, so thanks for the feedback. Hopefully it'll make things a little bit easier to see where I'm pointing at things in the diagram. So what we're doing here is adding an attribute latch. So the video RAM here is going to be toggling between the character value that goes to the character generator and the attributes, red, green, blue intensity values that we're going to be using. And the MA0, memory address 0 for the video RAM, is actually driven off the dot clock divided by 4. So within each character clock cycle, it will actually switch between the character data and the attribute data. So this is then latched in this latch here. And then we've got two PLDs, video out and attribute multiplexer. The multiplexer takes the 8 attributes out of here and works out what to send on to the video DAC, but it also provides a number of signals back to the video output PLD here, such as telling it when underline's enabled, when reverse video and various other things like that. So the two actually work together. And then these are both driven by the video enable, blink enable, and the black-white color values that are coming from the CRT control register. So the shift register provides the video output here, whether or not we want to show the foreground or background color based on the character output. The blink clock here provides the various clocks for the cursor and for the blinking characters. The cursor also provides the data to enable the cursor under the specific selected character as well. Between the video output and the attribute multiplexer, then the right signals should then be going out to the video DAC. What we will be looking at in later video will be how we can enable the color output for this Monochrome Display Adaptor, but to start with we're going to be focusing on just the monochrome version of this. So this is probably one of the most complicated parts of the original Monochrome Display Adaptor schematics that were included in the original PCXT technical guide. Now I have covered some of the items in here previously, so the things in green we covered in the previous video. So that was the video synchronization signal being divided down to provide the cursor blink and the character blink. And we also talked about the way how the color signals could actually enable the Monochrome Display Adaptor to actually output color as well. But so we won't be covering that. We're going to be focusing on the yellow bits for now. So what I'm going to do is just to take us through this, because as we go through looking at the PLD configuration, these things will become important. The video enable pin on the control register, if that's set to 0, then the card will not output any data. And we also discussed in the previous video that it would also suppress the horizontal sync signal if video enable had not been set to 1 since the previous reset. And if the video attributes 0 to 7 are all 0, then that actually results in non-display. And you will see when we look at the attribute values down here that non-display is basically foreground 0, background 0. The output of the character generator actually comes in the form of this S dots output. So this comes from the character generator and the shift register. So this is where our bit stream for our chosen character actually comes into this. Now this design includes 2 latches for the attribute data, and I'm not certain that we actually need the second latch here, but if we ended up with some timing issues then we might need to add another latch here, but for the moment we're just dealing with this latch here. Now the output of all this, we have an output, the intensity for the background, intensity for the foreground, and then we also then have alpha dots output and black and white video output. Now these two are a little bit confusing. They're basically the same signal. The only difference between them is that this output here is combined with reverse video, whereas this line here is not combined with reverse video, and this basically means that alpha dots is used to control the multiplexer for the foreground and background intensity, but reverse video doesn't reverse the foreground background intensity, whereas reverse video will reverse the signals down here. So you'll notice that a lot of the gates around here have got letters over them, and when we come to look at the individual PLD configuration logic rules, then we'll be referring back to these individual gates. But fundamentally up the top here we have cursor information coming in and the cursor blink, so this is providing some basic cursor information. Then we have the character blinking information and whether or not the attribute 7 has blink enabled. And then down the bottom here we have decoding of the attribute values for the foreground here and the background down here. At the moment, if the 3 foreground bits are 0, then we get an output here, and if they're equal to 1, then we get an output here. Now what we can see here is 000 is non-display, 001 is underline, and 111 gives us a white character black background. But if we have 000 and 111 as the background, then we get reverse video. And basically what these two decoders here do is decode the foreground and the background, and we get out of here whether the background is 0, the background is all ones, or if the foreground is 0 or the foreground is underline. And these are then combined through these various gates and things to provide the output. And this will combine the cursor, blinking characters, the no display, underline, reverse video, and all these conditions actually come out over here. So I won't go into too much more detail. The only other things I should say is that coming into here as well, we also have the CRTC row address or raster address lines coming in here to determine which line we actually output the underline. And in this particular case, it's row 12. In our version of the adapter, we're actually going to use row 14 because the characters are slightly higher. So the attribute details that we get for each character, the top bit 7, determines whether it's blinking or not. Now, if blink is disabled in the control port, then this will just be the background intensity. Although it's got red, green, blue there, we're only really treating that all zeros or all ones. And when we talk about the background, then anything other than all ones is treated as 0. And when we're looking at the foreground, anything other than 1 and 0 is treated as ones. So when we look at actually all the combinations of the attribute values, in fact, any combination of ones and zeros for red, green, blue, other than these two here, then will be treated as this. Where this output then comes, this is then actually sending the data out to the D connector that goes to the monitor, has whether or not we've got highlight, whether the intensity is enabled. We've got the video output here, which is whether it's 1 or 0, and then we've got the horizontal and vertical sync. And what we can see here is the alpha dots here enables this multiplexer here providing the highlight. B and W video provides the output going to the video here, and also this comes back to the status register. So this output here also goes to the status register. So the main difference between this signal, and this one here is that this signal doesn't have the foreground and background intensity values reversed when we get the reverse video. So it's quite for a monochrome display adapter, it's quite complicated. So here's the diagram as we left it last time. What we're going to be adding during this video is the attribute latch, the video output PLD, and the attribute multiplexer PLD, and this is the one that we added in the previous video, along with the control register here, and the status register, in fact, up here as well. So what we're going to be doing here is wiring in the data feed from there, from the left-hand side of the video RAM. So this video RAM is currently going into the character latch, and now also needs to be wired into the attribute latch. The output of the attribute latch is then going to go into the attribute multiplexer. We're going to need to wire in the enable blink, the two PLDs here. The video enable is going to go to the two PLDs. The black and white stroke color is only needed by the attribute multiplexer. And then there are quite a few signals that actually go between these two. Some are coming from here to here, and others are coming from here to the bottom down here. And you can also see down the bottom we've got our horizontal sync and vertical sync, and we'll be delaying those as we discussed in the previous video. So this will actually be taking in these two signals and delaying them by 1 character clock cycle. And because we've got a character clock going in here, it means with using these as a D flip-flop, we can delay them by 1 character clock cycle. And the output that's coming out of here, so the video is the main output that controls foreground and background. The alpha dots is the one that just controls the intensity for the foreground and background and doesn't take into account reverse video. Before we look at the breadboard layout, what we probably just need to do is to have a quick look at the configuration of these PLDs. These are by far the most complicated PLD configurations because the two are kind of tightly linked together. So this is the attribute multiplexer. This is probably the simpler one. It basically has the attribute 0 to 7 coming in, the video enable, black and white color, and the blink enable coming in from the control port. And then the output, it sends the required color palette value for the video DAC. It has an input for the video and the alpha dots coming in from the other PLD. Has an output telling the video output PLD when the reverse video condition is enabled. It also has another output to tell it when the underline is enabled and also when no display is enabled. And the reason for having those three is it just means that the other PLD doesn't have to have all the attribute values feeding into it. The no display condition here basically just says they need to have bits 0 to 2 and 4 to 6. So both the foreground and background need to be 0, and that comes out as no display. And if video enable is at 0, then we also get a no display condition. Underline basically just tells us when the foreground value is 001, and reverse video shows us when the foreground is all zeros and the background is all ones. Now the conditions down the bottom here are slightly more complicated in that we've got, first of all, the P4 output will actually tell us whether or not we're using black and white or colour. Now what I've done is, since the default values of the control port, black and white would be 1 and colour would be 0, and so what that means that wherever we have a not black and white colour, that will indicate that the value in this particular case will be the colour outputs. We're only using for monochrome the P0 and the P1 values, so this is the are we showing foreground or background, and this is the intensity. These other two values will be 0, and you can see here, because we've got this condition in here, that if we have the monochrome enabled, so black white is 1, then these two terms will be 0, so we'll get nothing out of there. And then when we have got colour, then it will output the appropriate signal coming out of there. And then down the bottom here is we've got combinations of, when we have got black and white mode, then the intensity will be based on the alpha dots value. So you can see here, when the alpha dots is 1, we actually get the foreground intensity. When alpha dots is 0 and blink enable is disabled, then we get the attribute 7, which is the blink or background intensity. And then we have another condition here. When we've got colour, when the video output is enabled, we'll get attribute 1, which is green for foreground, and when we've got the background, then we'll get attribute 5, which is green for the background. And then similarly down the bottom here, if we've got monochrome and we've got video output, then we'll get a 1 there. Otherwise, if we've got colour, then we'll actually get attribute 0, which will be blue for the foreground, or get blue for the background. The rules in here basically multiplex the monochrome between the foreground, background and the intensity, and then for the colours we'll actually get intensity red, green, blue for foreground and background. So if we look at the video out PLD, so this is the one that actually determines the output here is the video and the alpha dots, and we have quite a few inputs here. And it also is doing the horizontal sync and horizontal sync delay. You can see the inputs here. We've got the character clock, we've got the cursor input from the CRTC, we've got the blink clock for the character, we've got the blink clock for the cursor, we've got the video enable. S dots is the output from the shift register coming from the serialized character generator. Underline row address indicates when we're on the row address for underline, so this is coming from the clock PLD. Blink enable is coming from the control port, no display comes from the control port, and underline is coming from the attribute multiplexer when the foreground is 001, and reverse video is when the background is all 1s and the foreground is all 0s. So these are all the inputs coming in here, and basically the primary output here is the video output and alpha dots, which determines the foreground background intensity. Conditions here are really quite complicated, and if we refer back to the diagram that I showed you previously, so each of these letters corresponds with the gate and the various inputs which are going in here. So I hopefully have managed to implement this, but we'll see when we actually try this out with the test program whether or not I've been successful or not. Basically, a lot of these letters and things here refer back to the conditions that we have here. And so you can see that the various signals that are going into the different gates are actually represented here. But basically that alpha dots is the primary thing that determines are we going to show something or not. But then the video output is then exclusive ORed with the reverse video. And then finally, we've got the D-type flip-flop for the vertical sync and horizontal sync, and that will result in a delay of 1 character clock. So I won't show the programming of these. I'll compile them, program them, and then we'll look at fitting the chips into the board and look at how we're going to lay out the board. So I've already put the labels on the chips. So the attribute latch is going to be going into this position here. It's going to need to have a feed, probably using a DuPont cable with the 8-way connectors on it, feed from the output of the video RAM over here over to this side. We're then going to put the video output PLD down here. We'll probably need to move these horizontal sync, vertical sync cables, and then the attribute multiplexer is going to be going over here. Again, we need to move it over a little bit, and then there'll be quite a few signals going backwards and forwards and going between the control port here and the various things here. Once we've wired it all up, then the output is going to be going, the P0 to P4 is going to be going from there over to the input to the video DAC, and we'll need to leave the P7, P6 and P5 wired to 0, but the other lines are going to be connected to the output up here. So just remove the horizontal sync and vertical sync, plug in the chips. Now we're going to wire up the power and put decoupling capacitors in. Check the schematic. So we need to wire in output enable and the attribute latch. So output enable, just need to remove some of the wires to put the output enable in, put those back. And we're going to wire in the data bus going into the right hand side there. Then we just need to put the attribute latch clock in there as well. Then wire up the output to the input to the attribute multiplexer. So now we'll wire up the horizontal sync and the blink clock outputs. So blink for cursor and for the character. So now we're going to wire in the horizontal sync and vertical sync delayed outputs up to the connector there. Then we need to wire the video output and the alpha dot output between the two, and also attribute 7. Then some of the other reverse video, underline and no display coming out of the multiplexer down to the video output PLD there. We're just going to put the video enable and the blink enable up there, black and white, and then we need to wire the video enable and the blink enable together. Then the underline, and then the output from the shift register. So take out the digital analog converter tying to ground. So we're just going to leave the top P7, P6, P5 wired into ground there, and then P0 to P4 will be wired in from the multiplexer. So completed wiring up the board, and I did do a trial run, and there were just 2 minor things I needed to change. So I'd missed out the output enable pull down to ground there, and the other thing I discovered was that the A0 address line on the RAM switch between the attribute and the character, that was connected to the wrong clock. I needed that actually connected to the character clock QC rather than QB. So I've made those changes. Now what I'm going to do first of all is to try the original test program. So test 4 was the last one I used. Now this doesn't know about the control register, so I would expect it not to display anything initially because the video enable is not going to be set. So video enable is this output down here. And what I will do is once I've run it, I'll switch it between this pin and this pin, which is the inverted one. And I should then be able to see that. So that just shows that the video enable pin is actually preventing the output unless it is actually set to 1. I'm just going to switch on the nanocomp on so we can see 4.96 volts. I have increased the power supply voltage slightly so that we get a better voltage here. And all we're going to do now is to download the original test 4, MDA test 4 from the last video. I'm just going to send that. When I run it, we don't see anything. Now if I now switch the video enable from the positive output to the inverted output, what we now see is that is the pattern. So now let's try using one of the monochrome test patterns that I've got. So now I'm going to run MDA test 5, which should enable the necessary control port signals, and this will also give us green output, hopefully, in monochrome with blinking. Now I do just need to switch the video enable back to the positive one. So just going to send this down and press go. So you can see there we've got pretty much the attributes coming out. You can see we've got a mixture of some blinking, some reverse video, there's certainly some underlines and things there. So it certainly seems to be doing something. There are a few characters that seem a bit odd, and some of the attributes are not quite where I was expecting them, but it does look like it's working to a large extent. There might be a little bit of tweaking we need to do. And then I've got a further test program that disables the blinking. So I'll just load test 6, which just disables the blinking. And we can see here, because the blinking's been disabled, then when the attribute 7 bit is set, then it actually gives us the higher intensity background that gives us a dark green. So you can see here that it's actually coming out a bit better. This looks a lot closer to what we were expecting. probably need to do a bit more investigation, and in the next video I'll go through the test programs. We'll go in to have a look a little more detail at what's going on here. I suspect there might be a few more fixes and things we need to do to make things come out optimally, but it all seems to be working pretty much. What I'll do is to break the video here, and in the next video we'll do some more testing of the monochrome mode, and then we'll also look at the testing the color mode as well. So thanks for watching. If you don't want to miss out on future videos, please hit subscribe. If you can hit like, it just helps to make the videos available to a wider number of people. Thanks for watching.